All right, so one way in which we could start to dissect and analyze position or a change in position is motion along a horizontal line. And to imagine this, you can almost imagine like a vehicle that's moving in a direction either to the right or to the left. And sort of here's the way that the conventions that we could sort of apply to this. So if you imagine the car is sort of zooming down the road to the right, we could say motion to the right would imply that the velocity was positive. So by convention, we're going to say moving to the right is positive velocity, sort of like moving forward. If you're moving forward and your position is changing positively, then your velocity is positive. Similarly, motion to the left, we're going to call negative velocity. So motion to the left would be like if the car was backing up. And sort of these little lines are sort of like the air that it's moving through as it's backing away. So yeah, ultimately, just by convention, car moving to right, positive velocity, car is moving forward. If the car is moving to the left, then it's going backwards, and we call that negative velocity. We just need to sort of put our foot down to say which direction is positive velocity and which direction is negative. And this is the way that we do this by convention. You might think to yourself, you're like, wait a second, moving to the right, positive velocity, moving to the left, negative velocity, that covers a lot of the possible velocities out there, because of course anything, any value a particular function could take could be positive or negative, but it could also be zero. Let's think about this for a second, because if your velocity is zero, what would that tell you? Your velocity would be zero precisely when velocity zero means no change in position. That's when you are at rest. So if you were analyzing the movement of this vehicle, anytime it was moving to the right, we would say positive velocity. Anytime it's moving to the left, negative velocity. Anytime it's not moving right or left, zero velocity. And that seems to make sense in sort of an intuitive way as to how to describe the motion of this object. And now I want us to take this idea of velocity and extend it one step further, because like we showed in the last clip, that just like you can take a position function and take its derivative to get information about velocity in terms of a function, you can also take the derivative of velocity and get information about acceleration. Now what I want us to do is take a moment to grip the nature of acceleration with respect to the car. So acceleration in general is a change in velocity over time. That is precisely what manifests whenever we were looking at the slope of the tangent line on the velocity function in the last video. But one thing that I want to bring up, which is just a physical reality, is, and this actually relates to Newton's laws of motion, F equals ma, accelerations are caused by forces. Accelerations are caused by pushes or pulls. So now, let us try to get a grip on acceleration, because if you think of a push or a pull, one way you could sort of conceptualize that is almost imagine that the truck or the bus or the vehicle, whatever it is here, has attached to it like a rope. And you could pull in one direction or the other. So if you happen to be pulling to the right, so let's say this now below, these are acceleration facts, here velocity facts, here acceleration facts. If you pull to the right, we're going to call that a positive acceleration. And in some sense that makes sense, right? Because if you pull to the right was our direction of positive velocity. The right is similarly going to be our direction of positive acceleration. If you imagine someone tugging on this rope and pulling the car to the right, speeding it up to the right, that would be a positive acceleration. And on the other hand, you could also have an acceleration with some sort of rope or object attached to the vehicle pulling in the other direction. So if you're pulling to try to bring the car back to the left, a pull to the left, we're going to call acceleration less than zero. And now here is maybe the most intricate idea related to this, which is like the conditions under which the car is speeding up and the conditions under which the car is slowing down. And this is something to think about because my claim is, at least, that the notion of speeding up and the notion of slowing down relates directly to the velocity and the acceleration. So let's think about this here. Imagine the car is moving to the right. Imagine the car is moving to the right. So the car is moving towards, off the page to the right, or trying to. Motion to the right. So imagine the car is moving like so. Now, what would cause the car to speed up? Pulling to the right or pulling to the left? Well, pulling to the left would cause the car to slow down, in fact. In order for the car to speed up, you'd have to pull in the same direction that the car is traveling. So if the car is moving to the right, that would be velocity positive, and acceleration positive would cause the object to speed up, right? Velocity positive means car's moving to the right. Acceleration positive means you're pulling to the right. You're pulling in the direction the car is moving. That's going to speed it up. But on the other hand, the car would be slowing down if it was moving to the right, velocity positive, but the pull was going in the other direction, acceleration negative. If the car's trying to go right and I'm pulling back to the left, that's going to slow the car down. Okay, we've considered both cases where the car's going right. When the car's going right, it speeds up when you're pulling right, it slows down when you're pulling left. Okay, let's imagine the reverse scenario. Imagine the car is in reverse. Imagine the car is heading left. What would cause the car to speed up? Well, if the car is heading to the left, the car would speed up if you also pulled to the left. If you pull to the left and the car is heading left, the car is going to speed up. It's going to be going faster. If, on the other hand, you wanted to slow the car down, if the speed of the car was causing it to go left, then you would want to pull to the right. If the velocity was negative and the car is going left, if your pulling goes to the right, then you would slow the car down. It wouldn't be going to the left as fast by virtue of your pulling it back to the right. Now, let's take a look at both of these cases because I claim whenever you look at the speeding up cases and the slowing down cases, there's something in common between them. When does the car speed up? When the velocity is positive and the acceleration is positive, or when the velocity is negative and the acceleration is negative? In other words, if the velocity and acceleration have the same sign, we're speeding up. So, speeding up, velocity and acceleration have the same sign. What does this mean? What we're saying, velocity positive, acceleration positive, car going right, pulling to the right, speeding up. Velocity negative, acceleration negative, car going to the left and pulling left, that's going to speed the car up. Slowing down is when the velocity and the acceleration have opposite signs. So, slowing down, velocity and acceleration have opposite signs. And think about this, this makes sense as well. Because if the car is going to the right and you are pulling to the left, the car is not going to be going to the right as fast. It's going to be slowing down. And similarly, if the car is going left and you're pulling to the right, that's also going to slow the car down.